Transformations of exponential function. Before studying about the transformations of exponential function, you must go through the previous videos that in which we discussed about what is an exponential function, what are the laws of exponents, and some questions related to the rational exponents as well. In this video, we will basically discuss that how we are going to transform the exponential function's graph along the x-axis or y-axis, horizontally or in the vertical direction. What will the changes that we will observe? Consider the parent exponential function f of x equals b raised to power x. This b is basically the base and x is the exponent. So in exponential functions we have variable x in the exponent. The general graph for this parent function y equals b raised to power x is graphed like this. The y-intercept, this point is basically the y-intercept. At y-intercept we put x equals to 0. At y-intercept we put x equals to 0 and then we will get y equals to 1. So we will get the coordinate point 0 and 1. That is basically the y-intercept of this exponential function. Consider some laws that we will follow while drawing or graphing this exponential function. Y equals to b raised to power x plus c or minus c. Our graph will move vertically. If I have plus c, then my graph will move c units in the upward direction. My graph will move c units in the upward direction. And this y-intercept will basically become 0, c plus 1. I have this point as a y-intercept 0, 1 and that will become 0, c plus 1. And if I have y equals bx minus c, my graph will move c units in the downward direction. And both these operations will be observed in the vertical direction. If I have some constant that is added or subtracted with the variable exponent like y equals b raised to power x plus c or y equals b raised to power x minus c, the graph will move horizontally. If I have plus c with the exponent, then my graph will move c units in the left direction. And if I have y equals bx minus c, my graph will move c units in the right direction. If I have y equals minus time b power x, then my graph will reflect along x-axis. And if I have negative sign with this exponent, then the reflection will be over y-axis. Consider y equals negative time b raised to power x. I will first draw the parent function y equals b raised to power x. Negative b raised to power x, we will just get the reflection along x-axis like this. This is the graph for y equals minus b raised to power x. Consider y equals b raised to power minus x. First of all, I have drawn the graph for the parent function, that is y equals b raised to power x. And if I have y equals b raised to power negative x, then I will get the reflection along y-axis. This is the y-axis and I will get the reflection along y-axis. Now come towards some additional transformations, that is about the stretching or shrinking of the graph. The vertical stretch or shrink. If y equals c times b raised to power x, then I will have vertical stretch or shrink. If c is greater than 1, then I will have stretching, and if 0 is less than c is less than 1, it means c is between 0 and 1, then my graph will be shrinked. Horizontal stretch or shrink. If y equals b raised to power c times x, if some constant is multiplied with this variable exponent, then my graph will be stretched or shrinked in the horizontal direction. If c greater than 1, then my graph will be shrinked. And if c is greater than 0 and less than 1, then my graph will be stretched horizontally. Consider the general form of exponential function. That is y equals a times b raised to power k into x minus d plus c. This a is representing the stretch or shrink vertically, the vertical direction, this direction. The graph will be stretched or shrinked in this direction, like this. If a greater than 1, then my graph will be stretched, and if a is less than 1, then it will be shrinked. This b is basically the base. That can be any constant. And this k, when we come towards this k, that is basically the stretching or shrinking horizontally. This is stretching or shrinking horizontally. The graph will be stretched like this, and it will be shrinked like in this direction. And it will be stretched or shrinked horizontally by a factor 1 divided by k. If I have y equals b raised to power 2x, then my graph will be stretched or shrinked with a factor of 1 divided by 2. D, that is basically x minus t. This d is representing the horizontal translation. The horizontal translation, whether we are moving into the left direction or in the right direction. And at the end, plus c. This c is indicating the horizontal asymptote. When we talk about the asymptote, consider the graph for y equals b raised to power x. The graph for y equals to b raised to power x. This is the graph for y equals b raised to power x, and this is the y-intercept. Y equals to b raised to power x plus c. This c is basically 0 here. So the asymptote for this graph y equals to b raised to power x is y equals to 0. This is the asymptote, horizontal asymptote for this graph. And if I have y equals to b raised to power x plus 2, then my horizontal asymptote will be y equals to 2, and its graph will be this. When we talk about the domain and range, come towards the domain. Domain is always the set of real numbers. Domain is x belongs to set of real numbers. Translation basically do not change the domain, whether it is in the upward direction, downward, left, right, shrink, stretch, or reflection. Our translation do not affect the domain. So domain will always remains x belongs to set of real numbers. Range. For range, we will consider the asymptotic value. That is basically the c. If the function is above the asymptote, the range will be y greater than c. And if function is below the asymptote, then my range will become y less than c. Now consider an example. I want to draw the graph for y equals negative 2 times 3 raised to power x minus 4. First of all, I will draw the graph for parent function, that is y equals 3 raised to power x. This is the graph for y equals 3 raised to power x. This is the y-intercept, that is 0, 1. To get the exact points for this graph, consider 3 points minus 1, 0, 1 for x. Put these values for x in the function y. I will get For -1, I will get 1 over 3 value for y. For -0, I will get the value for y, that is 1. And for 1, I will get the value 3. And I can draw these 3 coordinates and then sketch the graph. Then I will move towards y equals 2 times 3 raised to power x. My graph will be stretched. The graph is stretched as compared to the upper one. The coordinates will become, I will multiply 2 with the values of y, and I will get these coordinates: -1 with 2 over 3, 0 with 2, and 1 with 6. So my y-intercept will become basically 0, 2. That was earlier 0, 1. Y equals -2 into 3 raised to power x. Simply, I will get the reflection in the negative direction along x-axis. The reflection is along x-axis. And what will happen with the values for the coordinate? Just multiply negative sign with the values of y. Now the final y equals -2 times 3 raised to power x minus 4. Now see x minus 4. My graph will move 4 units in the left direction. My graph will move 4 units in the left direction. And what will happen with the points, coordinate points? I will simply add, this is 4, I will simply add this 4 with the values of x. This 4 is basically changing with the variable exponent. So the change will be made in the x coordinate. So I will just simply add 4 with each coordinate, and I will get 4, -1, I will get 3, 4 plus 0, I will get 4, and 4 plus 1 will give 5. And the y coordinates will remain the same. And then just simply draw these coordinates and sketch your graph. The asymptote remained unchanged. That is basically y equals to 0. Horizontal asymptote. Since I have no c over here, this here c is null, that is 0. So my horizontal asymptote is y equals 0. The domain is for exponential function always set of real numbers, and it will remain unchanged during the transformation. Consider the range of original function, that is basically y greater than 0. Consider the range for original function. I got y greater than 0. I got all the values for y that are greater than 0. So range of original function was y greater than 0. Now for the new function, I got the range, that is basically y less than 0. You can see this y. I got the values for y, negative values, and that is in the negative y coordinate points. So my range will become y less than 0. Since my function is below the horizontal asymptote, so that's why my range will be y less than 0. For more video and updates, just like and subscribe the channel. Thank you.